Hi everyone, welcome back to my channel. So I attempted to kind of use Go as a language. I was just messing around writing a compiler in it many months ago, and I realized that I was just getting very annoyed by lots of things. And I found that Go has lots of problems, and I wanted to try and fix them. And I thought about, as a joke, maybe I could make something called TypeGo, similar to JavaScript and TypeScript, that tries to fix the language. I thought that as a joke, and then I decided to actually make it. And then I did actually make it. Here's TypeGo. So generally in Go, what's preferred is to use this kind of syntax. And the problem with this is generally the compiler doesn't actually check your code, and you get silent bugs, which I did actually show a silent bug. What I did before is I did this. I did that, and then forgot to do this. And then forget to do that. And you get a bug, and it just basically, well, now this is inferred as a pointer, and you don't want a pointer. I didn't want it to be a pointer. I just literally forgot to put this here. I forgot to put this here, and then didn't write an int. If you write an int and don't do that, you get errors. The compiler actually does things and tells you you made a mistake. It's wrong. If you just write this, it infers you wanted a pointer, and you didn't want a pointer. This is kind of the problem with inferred types. You're presuming, basically the compiler guesses what your types are. Another problem with Go is enums suck. They are terrible. They're the worst enums I've ever seen in my life. So the way you do enums is first you make a type, you basically make an alias for an int, and then you use this const iota, and then the problem is they're not just simply separate. They are global constants. So if I have, for example, if I take away this, now U16 is a global constant. And it will basically just pollute your entire namespace. And you can't make that like any other variable with that name at all. Which is kind of the problem. So you need to basically prefix everything with token type underscore, token type underscore, token type underscore. Pretty annoying. Because why would you make them global constants? It's terrible. And then you can't actually print them. I mean, there is a tool called Stringer, which I've never actually tried, but basically here I have to basically make a massive string array of 72, and every time I add one of these, I'll have to add one of these here as well, which creates human error. It's just garbage, honestly. It is absolutely terrible. So basically I wanted to fix this, because enums are really bad. They are so bad. And there are other things I wanted to fix as well, such as append. So the way append works, numbers 1. For some reason you have to write numbers equals append numbers. So why do I need to do that? Seems redundant to write numbers twice. But that's how Go is designed. You have to write numbers. Basically, I guess it takes in the slice. It's weird. I don't know. I just don't like it. And I just wanted to fix stuff. So I created TypeGo. So what the hell is TypeGo? So what is TypeGo? A tool to help improve and give Go some quality of life improvements. It converts to Go code similar to TypeScript and JavaScript. So here's an example of what this is. So we have package main, most of it's the same, but we have enum struct. So that's completely different. And we have a person, then we have a method. The method's inside the struct. And then this converts to this. So we can basically, this whole enum thing here, enum struct, converts to this code here. And basically it will convert it to a struct and then give it the values with those admin guest member. So we have admin guest member, converts that to a struct, admin guest member, and then you simply do role.admin, role.guest, role.member. And it's basically namespace. It's no longer just a global int constant, which is terrible. But there are also two options. I mean, I give enum and enum struct if you still want to have the iota style. And then, yeah, so the methods as well. So how the methods work is you just put them inside the struct. You still have to put the, here, you still have to put p dot. But it will basically, what it does is it takes the first letter, makes it lowercase, and then creates in the object and calls that. So user p.name, p.age, and then roll to string, p.roll. And this will basically just convert into regular kind of methods in Go. So p.person, and then p is used that. You know, it's basically just a lot easier to write. You don't have to write this. Also, yeah, the name, the type goes first. So basically, enum struct, role, struct, person. So the type, then the name, and then here string name, int age, int role. I just prefer it this way. Maybe someone would disagree. I just think it's unnecessary to put the type after. Why would you put the type after? It's just confusing. It's not how I think. And half the time when I'm typing in Go, I literally have to write this. So say I want an integer, right? All right, oh, it's an int, okay. Oh, wait, I can't write, okay, right. It's a var, okay, what's the name of it? Okay, I don't know, index or whatever, I don't know, something like this. So I literally have to write the type and then think, oh, okay, the type goes after, what's the name? It's like every time, because I'm just used to int index equals, like, that's what I want to do. I don't want to write, plus I hate this. I'll never do this, ever. I hate it. It's terrible, it's hard to read. Anyway, so yeah, so basically it's just a way of like converting to Go. There are a few problems right now. It doesn't have a language server. Well, I'm never going to make a language server because it's impossible for me to make because I'm not Microsoft or Google. But it does have. I'll show you later. Basically, I'll show you later. A question and answer. What is TypeGo? TypeGo is a transpiler that converts TGO files into Go files. Features no inferred types except in limited cases. Go is built based on inferred types, so you can't always use them. C-style declaration syntax. Type name equals value, improved enum syntax, and simplified struct methods. So why did you make Go? Believe it or not, this actually started as a joke. Yeah, it was basically a joke project. Basically, yes, it's fixing these things. Inferred types, enums are terrible, and many things are unintuitive and verbose, like append. How do I use TypeGo? So it's actually very simple to use. Here I have a basic project. Right, so this is just a tic-tac-toe project. So what I can do is I'm basically just going to delete the Go files and show how this works. So you do need a go.mod, but you can just generate that yourself anyway. Delete Go. Alright, so all we have now is TGO files in this project. That's all we have. And we're going to copy and go into this CD drive, right? And then basically we have TGO. We type in TGO, and it shows us a list of commands. We have usage. We have TGO help, which just shows this help message. TGO version shows the version. Here we're right now we're on 0.1. So TypeGo version 0.1. We have convert file, and we need the name of the file. Or we have convert directory, which just converts all the TGO files in the directory. So I'll just show you that working. So we go convert directory, and it's only done console loop. Okay, we're in the wrong folder. Let me actually fix this. So we're in the right folder now, right? So basically, if you want to convert directory, we do this. We go TGO convert directory, run that, and it shows you converting main.tgo, converting board.tgo, converting console.tgo, done. Everything's done. So then we generated the main.go files, and then we can just run it. Basically, we can go run dot, and it runs, and we have a tic-tac-toe game or whatever. Anyway, that's the basic idea. I'll just show you how. I mean, so I do have a few problems with spacing, but anyway, it doesn't matter. So the good thing about TypeGo is it's completely modular. You don't need to. You could write your entire project in TypeGo and then convert it over to Go, or you could write one file in it just to get better enums. That's it. You don't need to You don't need to. It's completely modular, entirely modular. I'll show you how. So we have the original. Probably the board is probably the best thing to use. So board has a load of enum structs. So we have piece empty ox because it's tic-tac-toe game, noughts and crosses. You have the squares. So it's like 0, 1, 2, 3, 4 for the square indexes. And then basically that will convert into this struct. That's the first struct. And it converts into piece to string. I do have to fix this because it really should do that. But it's just a pain to actually fix the formatting. That should be this. Anyway, and then square again, it just creates these enums. And they're basically just a struct with the values. And then we can just get the name that we want and just auto-generates it for you. So you don't need to imagine you would add another one and then you say 10 and then you'd add this to the end. You literally just do this, just bracket, I don't know, new value, convert it, and then it does it for you. You don't need to write it yourself manually. Most things are the same, really. So say, for example, we have int int array my 9, it converts to var int array 9. I try never to use colon equals except for the situations where I need to use colon equals, like in the for loop. The for loop, literally you can't write this. It will not let you write this. It goes like, no, what's this? You can't do that. It's literally like designed based around inferred types. I mean, you could do this. Again, I want to write the type first. It drives me insane. Equals 0, say it doesn't matter what. You could do that, but then this is now not locally in the scope of the for loop, and it could cause conflicts. Anyway, so for loops are literally exactly the same. You don't change them. There's no difference. So if you look here, reset board, it looks the same. Use colon equals. So colon equals. So basically, in switch statements, if statements, for loops, you can use colon equals. Everywhere else, you can't. If I show you what happens if you actually do write a colon equals, say index colon equals 10, for example, and we try and run this. Convert directory. First we should save it. It normally helps. It says unexpected type. Colon equals unsupported outside of for loop. Write int value equals 10 and not value colon equals 10. Basically, it doesn't allow it. Same with var. So yeah, basically how TypeGo works is it basically just focuses on functions, declarations, structs, and just ignores everything else. And if it's something else, it just prints the tokens, and as it is, it just basically ignores the rest. But var is one thing where it does check because it shouldn't exist. Why are you using var? You should be doing this. That's the correct syntax. Anyway, I mean there are some things like, for example, append. I'll show you my append syntax. So the way append normally works, of course, 0, something like this. But I mean, basically what it does is it looks for this type and then automatically inserts it into the make when you actually convert it over. You don't need to write it twice. You can literally just write make, and it's same thing if you write like a channel chan int. So I can't write anything today. Channel equals make. You don't need to write anything here. Just make, and it will work. I think it will cause an error if you do put the type in. I'm not sure about that. I'm pretty sure it will actually, but I don't know. Basically, you're not supposed to. Anyway, it doesn't matter. So to make append, you do numbers dot append 1 or whatever. That's like 10 times, like it's so much shorter. Because I mean, the regular way of doing it, you can still do the regular way if you want. If you want to be archaic and do numbers. I mean, there are some situations where you do want the actual thing because you could be like, say you append from another list, or I don't know. Say if you want to copy it. Say if you have something like this. You have numbers int numbers 2. Okay, numbers 2 equals make 0. Say you append to the numbers dot append 10. So you append to that numbers and you want to copy that numbers into the new, you can do this, number 2, and then you append to numbers and add that to numbers. So you can do that if you want, so it doesn't, you know, that you can use both. Basically, you can use append that way, the old way, or you can use append in the simpler way, just with dots, and it's just a lot easier to write. Same thing with structs as well. Anyway, I'm kind of going on a tangent here, but this is basically TypeGo. I'll show you some more examples. So functions, again, function. So you can write fn or you can write func. Your choice, doesn't matter. Fn shorter, so I'm going to prefer that. Fn int add int a int b. It's basically the same. It's just the same. It's just I flip the thing, so the type doesn't go at the end. Type goes first, just like C. I mean, isn't Go supposed to be based on C? So why did they flip the? I don't know. And yeah, the same. So we have multiple return types. It's exactly the same. You just put it before. That's it. Basic variables. So you don't need to write the type if you write a constant. If you write a constant, you don't need to write the type, but you can if you want to. It's your choice. There's no requirement to write the type if you're making a constant. And then colon equals is only allowed in for loops, if statements, or switch statements. Otherwise, the compiler will yell at you. And then some advanced types. So we have maps. Again, you don't need to write the type again. because it will just write it for you. You have interfaces, chan int. I think I had an error when I might have to actually check if that actually works. We have append and make. That's word repetition. Yeah, you don't need to write that in make and stuff. So we have structs. So you do have to write. So basically, it takes the first letter, and so it'd be game. So it'd be g dot start game started, g dot player account. That's basically it. I find this a lot simpler than writing in brackets g pointer. Also, it defaults to a pointer, so it will always be a pointer no matter what. Yeah, that's just explaining that. Enums. So yeah, we have two options. We have enums, which will basically generate the iota. So there are two options. Yeah, interfaces, they still work. Interfaces, interface logger. Just put the type first, and most things are unchanged. So this is TypeGo. I'm expecting hate mail from the Go people who like the Go syntax. I don't care. It's modular. You don't need to use it at all. If you want better enums, you can use it if you want. It's modular. So if you literally can just do this. So you have a Go project and you just want better enums. So you create file text. Let's say, I don't know. Just call it enums.tgo. Let's say, I don't know, package main, I don't care, whatever you want to call it. And then you just want an enum. So I'm just going to say enum struct my enum. I don't know. Go into this, convert directory. It now converts it. But see here, we now have this enum generated for you, and you can use my enum to string and get it printed for you. How much effort was that? Not much. This is TypeGo. I'll probably change it based on feedback. But that's TypeGo. Let me know if you have any questions. See you guys next time.